Hey guys, welcome back to another GCSE Maths video. This time, as you can tell from the title and from the screen, we're going to be making ratio problem solving questions super easy. Now, before we get started, we're going to start with a very tiny, I'm talking like 2-minute at best, description of what a ratio actually is. So hopefully no one skips this. This is really important. I'm going to show you why ratio problem solving can be quite easy. But before we get started, again, most people that watch these videos are not subscribed, so I would really appreciate it if you found any of this useful or any of my other videos useful. If you could just press the subscribe button, it really does help out a lot. In the description, you'll see a link to my website where you can book tuition classes in case you're interested. I've got space in science and maths. And of course, you'll have my email address where you can email any questions you have to me as well. So let's start with what the hell a ratio is. So let's say we have sweets, and I have one blue sweet and I have two red sweets. Okay. A lot of people write that as a ratio of blue to red as 1 to 2, which is true. But what a ratio actually tells you is the proportion. So this tells me for every one blue sweet, I have 2 red sweets, which means even if I had, let's say, 2 blue sweets, I would have to have 4 red sweets. Okay? So 2 to 4 is actually the same ratio. And the reason why it's the same is you can simplify both sides by dividing by 2. And you get 1 to 2. So it's actually the exact same thing. So the problem that a lot of people face is that some students will think that if I just add these two parts together, it would give me the total. But as you can see in this example, I could add together 2 and 4 and get the total. But if I add the total of this, I get 3, which is not the total. And here's the big problem. If they said that the ratio of blue to red sweets was something like 4 to 5, and they said work out the number of red sweets, that is an impossible question, because there are an infinite number of combinations that will give you the exact same ratio, an infinite number of solutions. So in other words, they will never ever just give you a normal ratio and ask for the number of something. They can ask for the fraction or the percentage or the proportion. They cannot ask you for the exact number without giving you another piece of information. And the reason for that is if I just have a ratio, there are an infinite number of answers for the number of red and blue sweets. This goes on forever, because if I times both sides by the same number, I get another combination that gives me the same proportion. So let's actually get on to some questions now. This is what I'm talking about. There are only yellow, black and purple buttons in a bag. The ratio of the number of yellow buttons to black buttons is 2 to 3, so I like to write this out separately. And the ratio of black to purple buttons is 4 to 5. And it says, given that there are less than 100 buttons in the bag, what is the greatest number of purple buttons? And this is where students get confused. What do you mean the greatest number? Isn't there just one answer? No, because of this reason. There's an infinite number of solutions. Now, if I said that there are less than 40 red sweets, then that means I have 1, 2, 3, 4 possible answers. But if it's asking for the greatest number, all of a sudden, there's only one greatest number. It's 40. Well, if it's less than 40, I guess it'd be 20. And that's it. So in this case, we're going to work out what the maximum number of purple buttons can be, given that the combination of all 3 of those buttons should add up to less than 100. Now, the first thing we need to do is we need to actually combine these ratios. So as you can tell, they give us different proportions. Yellow to blue is 2 to 3, blue to purple is 4 to 5. And a good way to do this is to make the common number the same. So we're going to make 3 and 4 the same number. Some people like to write out like this, as like a table. So we have 2 to 3, and then for this we have 4 to 5. If we want to make these two numbers the same, we look for the lowest common multiple. The lowest common multiple is 12. So what do I times the first one by to get to 12? I times by 4. So that'd be 8 to 12. What do I times the middle one to get to 12? I times it by 3. So that'd be 15. So that is our ratio for the number of yellows to blues to purples. So 8 to 12 to 15. Now there's less than 100 in the bag. Well, if I quickly add up these parts, 8 plus 12 is 20, plus 15 is 35. Okay, so we're just going to work out how many times 35 fits into 100, which is actually quite easy. It only fits in twice. So all we're going to do is we're going to double all of these numbers. And again, if you add these up, 16 plus 24 is 40, plus 30 is 70. So, remember, this is the ratio of yellow to blue to purples. That is the greatest number of purple buttons. How do I know this? Well, there's two possibilities. There's either 15 purple buttons or there's 30 purple buttons. They want the greatest. Well, what's bigger, 30 or 15? 30. That's it. How cool is that? So they don't always say, oh, it's less than or whatever, or use an inequality. Sometimes they literally tell you how many there are. So here we have the number of houses and the number of flats are in the ratio of 5 to 3. So let's write H to F, that's 5 to 3. And then flats to bungalows are 6 to 5. And they tell me that there's 50 bungalows in the village. So again, we want to combine the ratio first. So some people, again, like to use a little table, H, F, and B. So 5, 3, 6, 5. The lowest common multiple here is 6. What do we times the top one? So 3 times what gives me 6? We times it by 2. That's 10 to 6. And we times this one by 1 if you'd like. So that makes it 5. So the houses to flats to bungalows is simply 10 to 6 to 1. So 5. Oops. Cool. Now it says that there are 50 bungalows in the village. So I know that this number is actually meant to be 50. Now, because ratios represent proportion and that proportion won't change, what do I times 5 by to get to 50? I times it by 10, which means I times the other two numbers by 10 as well. So 10 times 10 is 100. 6 times 10 is 60. So how many houses are there? There are 100 houses in the village. Again, the proportion should never change, which means whatever we do to one number, we do to the others. This is the simplest way to do it. I have got some other funky questions, so do bear with me, but that's it for now. I love this question. The perimeter of a right angled triangle is 84 centimeters. I like to draw out the triangle. And they're telling me that the perimeter, so all of the lengths added up is 84 centimeters, and the lengths of the side are in the ratio 3 to 4 to 5. What's the area? Now, if you remember, to work out the area, we just need this side times this side. Now, the first question I got asked by some students is, how do I know which side's 3, 4, and 5? And I said, it doesn't matter. Well, there's only one side that matters, but it doesn't matter which way round we label these two sides. It does matter which one's the hypotenuse, though. The hypotenuse is just the biggest one. That's all it is. And then 3 and 4, it doesn't matter which way round. Why not? Because when we times numbers, it doesn't matter if we do 3 times 4 or 4 times 3, we get the same answer. So, all we need to do is, if we add up 3, 5, and 4, that gives me 12. But we want a perimeter of 84. Currently, I have a perimeter of 12. So if I want to make this equal to 84, what do I times by? I times by 7. So I'm going to multiply all of these sides by 7. So draw out another triangle. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35, which means the area is just going to be 21 times 28 over 2. And I'm not going to do that in my head because I can't. Actually, could I? Maybe. 294 centimeters squared. And for 4 marks, I actually think that's a very good question because it combines together a few different topics. So it's tricky, but look how short it is. And all we're doing is we're using the same logic, the idea of proportion. If one side doubles, all of the other sides double as well. Using that fact over and over and over again. This is very similar. So Rosie, Matilda, and Ibrahim collect stickers, and they give us the ratio. So I'm going to rewrite this in a format which doesn't make my eyes bleed. We get 4 to 7 to 15. And it says Ibrahim has 24 stickers more than Matilda. Okay, Now, if Ibrahim has 24 more stickers than Matilda, and the difference in these two parts is 8, right? 15 take away 7 is 8. That means those 8 parts should equal 24, right? Because he got 8 more parts than Matilda, and he got 24 more stickers. Those two things are the same. And it says Ibrahim has more stickers than Rosie. Well, first of all, let's work out how much one part is. That's 3 stickers. And that means we can work out how much each person gets. So Rosie, she has 4. 4 times 3 is 12 stickers. Matilda, I'm going to write Matt, which is probably a bit confusing, but Matt gets 7 times 3, which is 21 stickers. And Ibrahim, which technically, by the way, since we know Ibrahim gets 24 more than Matilda, we could do 21 plus 24, or we could do 15 times 7. Sorry, 15 times 3, not times 7, which is 45 stickers, which is again the same as 21 plus 24. And it says, Ibrahim has more stickers than Rosie. How many more? Well, he has 45, 12, which is 33 more stickers than Rosie. That's it. Okay. So in these ratio questions, every year are answered quite poorly. But what you have to do is break down the proportion, work through it, take your time. These are 3 or 4 mark questions as you've seen so far. That means you get 3 or 4 minutes at minimum to do them. Here's a question that probably came up in a lot of your mocks because this question was really badly answered. And so quite a few schools that I'm aware of use this question in their mocks to see who really understands ratios and who doesn't. So we have 4 types of card in a game. If any of you have played with normal playing cards, it's fairly similar to that. But each card has either a black or white circle, a black or white triangle. So any one of those 4 shapes and colours. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Well, the best way we could work this out is if we had the number of black shapes over the number of triangles. That's probably the best case scenario, right? Because then we can just put them as a fraction, job done. And there are so many ways to do this. The way that they do it in the mark scheme, the way I've seen a lot of teachers do it, the way I've seen some students do it, is using a lot of fractions. And in my opinion, that's a bit uggers. It's a bit ugly. This is a 4 mark question, but you can do it very quickly. Instead, I like to use logic. So here, they've broken up the colours of the shapes into 8 parts and the shapes of the cards into 9 parts. Now, logically, these number of parts should be the same because there's the same number of cards in a deck. So in a normal deck of playing cards, you have 52 cards. Now, if I say 1 to 3 of them are, spades to not spades, and let's say 1 to 3 of them are aces and not aces, maybe we should use a different value. But the idea is, because they're playing cards, they should have the same total, because they have the same number of total cards. So in other words, if we change this into their lowest common multiple, which is 72, I should be able to get the exact proportion of each of these cards, because we can make that into one big ratio. So to do that, I'd have to times this one by 9. So if we do black to white, times by 9, you have 3 times 9, which is 27. 5 times 9, 45. Then we also have circle to triangle. We're timesing it by 8, because 9 times 8 is 72. And we get 2 times 8 is 16. 7 times 8, which will give you, and again, remember why this works? So my overall ratio is this. Now I know what some of you are going to say, can we also do 144 or 288 or anything else? Yes, but remember, we're looking for a fraction. Fractions are proportion. So for example, if I have 10 sweets and you have 20 sweets, I have half as many as you. But if I have 20 sweets and you have 40 sweets, I have half of as many as you. If I have 30 sweets and you have 60 sweets, I have half as many as you, and so on. So even if you made this out of 288, you'll get the same answer in the end if you simplify your fraction. So again, just remember the logic. Both of these ratios should be out of the same total because the total number of cards is the same for both of them. We know all of the cards are black or white and all of the cards are circle or triangle. So in total, the number of circles and triangles should be the same as the total of the number of black and white shapes. It should be the same. Then all it says is black shape, triangle. So black is 27, triangle is 56. And that's your answer. That's it. Pretty good. And again, I'm just using the fact of ratios, right? I'm just using the proportion fact. That's all I'm doing. The last thing I see very commonly in problem-solving questions with ratios is when you have algebra. And the only way they can do this is if they tell you what it's equal to. So sometimes they'll say 2x minus 1, x minus 4 equals 2 to 1 or something like that. But sometimes they give you another set of algebra. Now here is the deal. I'm going to give you two equivalent ratios quickly. Hopefully we can all agree that these ratios are equivalent. Look what happens when I divide the right number by the left number for both of them. I get the same value. Look what happens if I divide the left by the right. I get the same value. Now this should make sense to you because remember it's proportion, right? If they have the same proportion, then that means their fraction should be the exact same as well. So we're going to use that fact in this question. Now here's the only caveat. If I did something like divided the left and the right to get 1 over 4, but divided the right by the left to get 4, I do not get the same answer. So you need to make sure you're dividing in the same order. And you can choose, sometimes it's easier to do one than the other. For example, if one side's 1, you probably want that being the denominator. But what I'm going to do is I'm going to take the left side divided by the right side. And that should be the same as the left side divided by the right side again. Remember, it has to be the same order. And then all you're doing is you're solving this algebraic fraction, which of course is really easy, right? No, not really. The first thing you do is you'd cross multiply. Is that 16x or is it 6x? No, it is 16x, cool. So I get 2x minus 1 squared. In fact, I'll write it out like this. Let's write it out properly. And then all you do is you expand, move to one side, yada yada yada, job done. So 4x squared minus 4x plus 1. We have 16x squared. That would be minus 64x plus x, so minus 63x. Then minus 4. Let's move everything over to the right hand side. So we get 0 equals 16x squared minus 4x squared, so that's 12x squared. Minus 63x plus 4x is minus 59x. Then minus 4 minus 1 give me minus 5. Can we simplify this? Not that I'm aware of. So what we're going to do is use the quadratic formula to solve this. Some calculators, like my amazing one, actually does the quadratic formula for me. But again, hopefully the quadratic formula isn't too bad. And I get 5. Bit anticlimactic, I know. Or minus 1 over 12. So the question is, which one is it? Well, with ratios, we can't have negatives, right? I can't say that I have negative 2 times the amount of whatever than you. There are niche cases where you could, like with money. So if I'm £100 in debt and you have £50 in the bank, I guess I could say I have negative 2 times the amount of money. But again, we don't normally say that. So the answer is x equals 5. That basically takes us through every single possible type of ratio question they can ask you. Now, I will say that situations like these, they may change them. Of course, right? Like that's just, we have to expect with Edexcel. So it's not about memorizing, oh, if they talk about houses and flats, this is what I do. If they talk about triangles, this is what I do. They may give you triangles, they may give you houses and flats, but they may also change it. So make sure you understand why I did what I did and why it works, more importantly. That's the key learning from this.